Welcome to a new test and teardown video. I'm playing with some more Brüel Kjær today. A balancing demo unit WA0155. And if you Google around, you're not going to find anything at all. So is this a very, very special unit? I don't know. If you are able to find any kind of documentation, please post a link so we got everything together. I think this is probably for accelerometers or some sensors or maybe a brake, or maybe you can, I don't know what you can do with this exactly. Motor speed, I understand, and on off, that is probably the motor, right? And if you look at the two rotors, they are of course just connected together, and there's a good stable ball bearing. But there's a, listen to this really weird sound, and this one got a reflective sensor here, so they have been using this for sensing the speed or something. We got threads all around here, so I think the idea is you put in some screws like this, or something that is heavier or lighter, or put more or less, so you can create an unbalance. Probably that is what it's for. As you can see here, if this one is at top, let's look at the other one, then this one is not at the bottom but a little bit off, and here's a screw. And then they put some black tape around the edge, except for this shiny little point. And then there's another Brüel Kjær product called MM0012 0012. This is a photo-optical sensor, and that is of course used to detect the speed, I would assume. The fun thing about that one, look at that. It's not a normal BNC, but it's a two shielded, or two extra, I don't know, what is that? Let's look in the documentation and see if we can figure this out. If I find something, I will put it in here. Embed a picture of the data sheet of this sensor. So that's probably ground and power supply and signal out. Obviously you need 3 signals for this sensor. It looks like really, really nice. I got no idea about that one. And here in the back, it's really, really heavy, by the way. Power. So there's also a power for the main unit, and motor fuse and a main fuse. Really? Why is that necessary? So if you unscrew this, how are you going to... Aha! Look, there's an opening. There's a slot in the sides, so you can probably slide out each of the sides. But how about we just power this up first and see if it will spin. Then we'll play a little bit and see what's going on here. So now I'm going to try and enable power supply, and the power consumption is 2 watts, and I put the motor speed down. And, ooh, it actually... Oy, 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 oy. It goes absolutely nuts, and 70 watts. That is probably not how it's supposed to go. Whew. So I will try and play with... So, shit, it's going... That is not so good. I'm probably gonna go remove the screws because it's not in balance at all. Hang on. So let's try again. I remove the 2 screws. As you can see, I put them right here. And then... it goes really... that is not good. That sound. I'm actually always a little bit afraid, I don't know, respect stuff that rotates. I'm just saying. Because that was quite fast. Shit, man. I better measure what kind of speed that is, but that was something that's not supposed to sound like that. And we are inside this lovely unit. See, that's the slots for the... and that is a really big and nasty motor. And that is the speed control PCB called WX086. Oh, okay. So what's there? One little op amp and some little thingies. I don't know. And probably a little transistor or stuff like that here. And that is why it's so heavy, this big transformer. Oy, 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 oy. And also, I think I already know why this is not working. Let's get a little bit of light here. See, there was supposed to be some sort of a rubber band, and this is obviously some sort of a speed sensor that is connected to the rotor. So that is probably why it's going absolutely bananas, because it's not detecting any kind of speed. So that is what we need to solve, a little sensor. Why is this coupled like that? Because that rubber band is obviously not going to work. So this is just a normal elastic band, not good. And it's also stuck in here. We need a more proper band to have this up and running. So I'm a little bit stuck here. I'll be going to, I think I can measure the distance and the diameter of this, and then it's actually possible to get a band that will solve this and see if it works. Or maybe, I don't know what else I could do. Just get one of those crappy rubber bands just to prove this stuff is working. So how is this motor speed regulated? So this pot obviously goes to the PCB, right? So that's just, I don't know. Yeah, see? Okay, so the pot is just the yellow and the blue wire. It goes over here, all the way over here, and then, oh, there's also yellow here. That is weird. Okay, so the pot blue, did you see this? The yellow from the pot goes to the sensor of some sort. That is special. So then it becomes brown, and then it goes, aha, that is the on-off switch. Okay, so there's a green, orange, brown on the on-off switch, and a resistor for the, okay, so that is not interesting, but that's okay, so that goes also up here. Yeah. Wow. How do you like that? That is cute. So that is the rectifier something. 10,000. Okay, so what is actually written on this Aha, 24 volts, 2.2 amps. Aha! So that is how it works. Just a series regulator down here. Yes, a tip 126 Darlington transistor, right? So that is what it is. Series regulated DC. Nice. But I still haven't understood exactly how this sensor works. But that is something to check. And it goes super smooth, as you can see here. So what kind of stuff is that? And it goes in series with the pod. Yeah, a little bit special. There's also a little weirdo sound here. Haha! You're not going to believe it. I just asked my wife about rubber bands and she showed me her collection. And what do you know? That took me like 10 seconds to figure out. No, I got a lot. I should be able to find one that will fit here so I can carry on with this experiment. What kind of luck is that? So here's what I did. I found a elastic band that matched the size here. I did a little bit of experiments with markings here and turning this around, and it seems to work quite well and quite stable. So let's try and boot this up again and see if it works. Like that, and then is it on? Yeah. And now, look at that. This is the motor regulation lamp. So I guess the regulation system actually pulses the motor. I think it's actually it's a lot more visible on the video compared to real world. So every time I accelerate, you see, the motor gets more speed. And what happens if I brake? See, the regulation feels that it needs to give more power to keep the speed going on. So that works perfectly fine. This really weird sound you can hear. Let me show you what is actually the cause of that. Can you see the problem here? This shaft is bent. So someone threw this in the bin. And it landed on one of those big discs and bent the shaft. I don't know if I can solve that. Someone could maybe do that. At least we could just try and see if we could make it a little bit less bent. How about if I add with a pen some marks on this and then try and bend it back, I don't know, and then carefully hit it with something. I mean, this is impossible to bend, right? I would assume so. This is solid aluminium. I could also try and put on the other one here and then verify it's the same, but I can really feel if I look down here on the shaft. Let me try and get some light on. I don't know if this is visible. It goes all the way, see? It is definitely the shaft that is bent. And you can actually hear the bearing is loaded with this kind of problem. So this system is not going to work at all for its original purpose. I was looking a little bit at this circuit. So yeah, why is it not in focus? An op amp and transistor and a little trimmer and and a series regulator. So that's kind of what there is to it. That's quite neat. This product. Whoops! I think I want to try and play with this sensor here. So we might as well just assemble this side again. Yeah, they put in three set screws. So that is quite neat. So now it's working again, more or less. I kind of gave up straightening up the shaft because this is something that requires a little bit more finesse than just finding a hammer and trying. But I've marked here where I would like to hit it and then see if it works. But I mean, what if I bent this? I don't know. Or damage the bearings and stuff like that. It's probably not such a good idea. We just need to live with the noise so far. Now I want to play with the sensor. So I don't have this very special connector, but what I found in the manual. The manual says this is ground and this is +10 and this is the output in the middle here. So maybe I could figure out how to access this and maybe connect my scope. I don't know. This is what I'm gonna play with the next few minutes and see if I can connect this. I don't know. I'm not really super proud of the connector I've made here. But I mean, if it works, it's not stupid, right? I just wanted to verify if this sensor is working or not. So, here is the shiny part. And look at that. Let's go like this. So you can see both. Shiny part is passing the sensor. So that is working. Let's run the motor like that. So I mean, woo. So you can adjust for whatever kind of speed you want. Isn't that just cute? And do all sorts of science experiments. That is really nice. Ooh. And it's rock steady over there because it's feedback regulated and all that kind of stuff. So I think this concludes this video. I'm done playing with that and the sensor works and whatnot. Maybe I'll just show the data sheet of the sensor. So here is the MM0012 sensor, photoelectric tachometer probe. I got no idea how expensive that is. I'm so sorry about that. I didn't check out the internet, but if you know what is the normal cost of this sensor, please comment. That could be cool to know. And this is exactly how the sensor responds, if it's dark or shiny and all that, white stripe on a black background and all that. And it also shows the output voltage versus distance to your reflective surface. So you can even measure from 25 millimeters distance. Obviously you're gonna get a much lower output, but it is certainly possible. It also looks like it's better between 1 or 2 millimeters, like the shorter the better, more or less, and then it goes bad again. And here we see the connector. So it's called a BNT connector, not BNC. It looks a lot like BNC, but it's called BNT. And this one got 2 inner shields or inner connectors like that. And that is what I was able to connect to using my little homemade idea. And here we got the measurements of that super nice sensor. I think it says 200 microseconds. Yeah. Not a lot much more to say. Thank you very much. See you tomorrow. Bye bye.